Hey, everybody. Welcome back to the podcast Adventures in Machine Learning. I'm one of your co-hosts, Ben Wilson, and I'm joined today by
Michael Burke. Hi, everyone.
Yeah, today we're going to have a rather interesting conversation about something that both of us wanted to talk about, and I'll let Mike do the intro for it.
Yeah, so one of the things that I have found really interesting is how more senior people frame problems and how they leverage their experience to either make shortcuts or to develop more complex solutions where needed. So I thought it'd be interesting to take a case study of creating a trading bot, and I would ask Ben a bunch of questions and Ben would answer them with incredible wisdom and poise. And where I have experience, I'll try to jump in as well. But I think a trading bot is a very good end-to-end product that requires ETL, theoretically machine learning, and just lots of data engineering in general. So I thought it'd be really cool to see what Ben's experience is and how he would approach this problem.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So starting off, it's important to think about the scale. Ben, do you have any experience with either personal trading bots or things at a larger organization level?
So I've never built one, but I've seen other people's. I've seen hobbyists build some cool stuff that we would classify as like, okay, this is kind of like a demo that somebody's building. And I've known people that have run them on cloud-based hardware and tried to do some algorithmic trading. Typically, they're targeting stuff that doesn't have a whole lot of volume associated with it or doesn't have a lot of activity. Because a hobbyist who wants to build something like this, if you're trying to compete with like a Wall Street firm, good luck. I've also seen how Wall Street firms do this sort of thing, and we won't go into the details of things that I've seen that they do, but suffice to say, it's rather advanced. And a lot of it it's not really machine learning. It's more statistics-based, hard-coded algorithms written in really low-level languages. Sometimes it's custom proprietary hardware that's created in order to do that. So with that frame in mind of we're not going to be targeting like high volume, high returns, and high risk sort of trading, something that's more reasonable where the trade volume, we don't have to worry about, hey, the price is fluctuating every couple microseconds, or milliseconds. So something that we can take some time to be able to provide a bid of activity.
Yeah, so that makes a lot of sense. If you're doing millisecond or microsecond trades, you would need to rely heavily on low-level languages, as you said, speed of the pipeline, speed of the decision process, and also proximity to, as you said prior to starting the podcast, proximity to the actual New York Stock Exchange actually matters. So with all of these organizations working to develop really fast algorithms, the speed of light between Beijing versus New York will make you lose relative to if your server is right next to the stock exchange. And that's crazy to me. I remember reading that in the newspaper, whatever, some source somewhere several years ago, and that just blew my mind. But that's really cool. So let's say that we're not a billion-dollar hedge fund, and instead we're hobbyists looking to just have some fun and hopefully make $1,000 or $2 or $1 million or $2, or I wouldn't turn down $1 billion. but just make a little bit of money on the side. How would you approach this problem? So there's the problem statement is we're looking to make something that makes some money. How would you start?
First thing is who's working on it with me. And because it'll be a big undertaking, a lot of time to do this. The algorithm itself isn't going to be that complex or time intensive to develop unless you're developing something novel and really trying to play at making from this. Then you're talking about probably years of effort that are going to be involved in it. But if this is just a hobbyist thing, like, hey, we've got a couple of friends, we have some spare time in the week, we want to just build a project to see if we can do it and learn along the way, which is great. Like, that's new things. So I'd ask what people's time commitments are, what our end goal is, and what our level of acceptable risk is. And once I have those discussions and say, like, hey, how much money are we going to put into this? And how upset are we going to be if we lose all of it in a week? And if I didn't have the resources to do that, and everybody was sort of like, nah, I'm not cool with losing 10 grand of my money in a week, then we'd go find something. We'd write a Twitter bot or something. But saying that we have the resources and are okay with the risk, then start looking at how other people have done it. And that just involves a lot of research. Scour the internet, how people have done it, and try to look at repositories that might be online about people who have attempted this and then shared the code. And this isn't to say we would be copying that. You don't really learn that much by just writing somebody else's code. It would be more like just understanding by looking at prior art and saying, oh, that's clever. Maybe we should try that this person did. Maybe we'll do it differently, but at least we have an idea of the sort of data that they were using for. And I'd start listing all of that out of ideas. And after going through and evaluating the elements of things that we would want to check, create this big idea board. Hey, here's 20 things we're going to test out. That doesn't mean go and write 20 implementations of something before even a single line of code is written. It's for each of these ideas that we have, what data do we need? And we just list it out. We're like, okay, we're going to attempt to do an implementation where we're just looking at the endogenous elements of the financial trades. So just what is the value of this particular thing that we're trying to buy? Create a univariate model would be what would follow from that. At that point, all you need is just that data, the historical trade data, and the ability to acquire the most recent value of it as quickly as possible. So you're looking at streaming, definitely, if you're going to be doing something like that. And then maybe some other, to the far other extreme of complexity, you might be talking about setting aside something like ensembles. But we're talking about a single algorithmic approach. Maybe we need some, exogenous data to this time series, where we want to know major information that could have affected the market price of this particular stock at this time. That can become quite the rabbit hole of data that you need to acquire. Most of the really good data that's out there for this is behind a paywall. So even if you want that really fast, up-to-date stock trade data that is not displayed on the internet, it's not something that you go to Google Finance and you click refresh. That's not hitting the API that's controlled by NASDAQ. You got to pay to play to get that data and that data feed. And it is not cheap. That's why NASDAQ is a company and it's in business, is because it sells their data, the data, but it sells it in extreme volume where you're not getting the stock price per second. You're getting the stock price per millisecond or microsecond. It's an obscene amount of data. So if you need to do that, if you need your project, it's that's the guiding principle of what the goal is of this trading bot. That has to be factored in to the equation, saying,
got it.
In order to get this data, we need to buy it. This is how much it costs. This is what our infrastructure needs to look like to just be able to ingest that data. All of a sudden, it becomes rather expensive.
Yeah. So let's take a bit of a step back. So the first step that you mentioned is get time commitment of people, figure out the end goal, acceptable level of risk, amount of money, etc. So it sounds like what you're trying to do is find deal breakers as early as possible and not even waste any time starting the project if you know it will ultimately fail. Is that
Yes.
the correct interpretation? Okay, cool. That makes a lot of sense. And Ben and I were sharing some articles this week. And one of the core principles that I try to follow, and I think a lot of successful organizations try to follow, is failing as fast as possible. And there's the whole like fail fast startup mantra. But if a project is going to fail ultimately, you want to know that as soon as possible and sink as little time as you can into that project. So by assessing people's level of commitment and whether it is something you actually want to do, that really speeds up the process, because no matter how good your bot is, if people won't accept the level of risk or aren't interested, there's no point. So first step was find deal breakers. Second step was look at repos and existing code. Why do that instead of starting from scratch?
It's just dangerous. Even the most storied, sophisticated tech company out there, we refer to them as like FANG companies. Well, that acronym has changed over time, but effectively these massive companies that hire some of the best technical development people in the world and pay them a lot of money to do what they do. They don't do stuff from scratch unless they have to. So, for instance, at Databricks, when we are rolling out a new feature that's going to be released to our customer base, we're not approaching it from a waterfall design. We're not like, hey, what are all the features that the end product needs to be? And in order to build all those features, there's no pre-existing solution that exists. So we have to do this from scratch, from the ground up. You're going to delay getting feedback on whether this is a good idea or not by maybe a year, maybe 2 years. It will take forever, and you'll dump millions of dollars into this project that could just fall on its face and be completely useless. So that startup mentality of fail fast applies to prototyping of things. That MVP, that minimum viable product, sometimes is, hey, let's use this open source code. Let's make some small modifications to it, because we don't care about the implementation details. Like, we have software engineers that can figure it out. Like, can we build it from scratch? Hell yeah, we can build it from scratch. But it takes time, and that takes away time from doing other stuff that we could be doing that could make our customers happier. So the fail fast mentality of let's cobble together something that does the bare minimum with the least amount of effort that is at least acceptably stable, and then ask if people can try it out, but warning them like, hey, this could totally break. We'll be there to fix it for you if it does, but like, hey, can you just tell us if this is what you want? And we just listen to the customer. We gather their feedback. So even this can apply to small projects as well that a small team is trying to play around with. Like, hey, let's see what other people have done and let's test it. Instead of let's open up a prototype implementation to our entire nest egg of funds that we're going to use for this project. Let's see what happens with $100. Like, does this thing, like, is this doing something that we want it to do? And your risk is relatively low. You're going to find out pretty quickly. Just say, hey, we're going to turn it on for 6 hours, see what happens. You could make $400. You could lose all 100, and then your account is zero and you're done. You just know up front, like, okay, that was not something that worked well, but you're going to learn. And that's almost like a priceless thing for you, is to learn from that failure or learn from that success. It lets you know if you're going down the right path.
Yeah. One thing that struck me as really interesting, that you just said, which is the goal of leveraging other repos and other ideas. I think there are a few, but you said that it can really save development time in terms of developing prototypes. And once you have a prototype, you can start incrementing. So there are like two different extremes of development. The first is building stuff out of thin air without any prior version. And then the second is incrementing. So you can sort of think of it as version 1.1, 1.2 versus 1.0 versus 2.0. 2.0 probably leverages 1.0 to some degree, but it's more of a new thing. And instead, what you're trying to do is get into the small increment cycle. Is that more sort of what I'm hearing? Or would you still be developing giant breakthroughs with your model?
So one little caveat, 1.0 implies that that's your first production release of something by like versioning standards. So your first prototype that'll go out is going to be like 0.1.0. Maybe it's a dev build. And if there's something out there that's in the open source and you legally, this is an important point, you legally can use that software. So look for your license file in anything that's online. Make sure that you're covered there. Don't steal somebody else's proprietary code. That's bad. You can get sued. So look for, okay, it's BSD license or it's MIT or Apache or something. And then contact a lawyer and say, is it cool if we were to use this? Once you've qualified that and it's something that you're like, okay, we can adapt this or we can use this tool to service as this element of this application that we're building. That's cool. That's just a prototype that you're building. That may all get completely ripped out by the time 1.0 gets released. Because you may find that, yeah, we did that to save time and effort, but it's not what we really want. We need something more robust. We need to re-implement something from scratch, maybe. But you only do that if you need to. Now, if there's nothing that exists, there's no open source package that solves this problem, or it's such a new thing that you're maybe the first to go down this path, and you've verified that by doing your adequate research, you can still build stuff from scratch in sort of a hacky way. Just get it working, make sure it's tested so that it's not producing like wrong information. But you don't have to build out this super robust, highly advanced, feature-rich thing to solve this problem. Just build the minimum amount to make it so that you can test whether it works or not in the real world. And then later on, you can add those features. So 0.2 release, maybe you add some new features that are good to haves. By the time 0.8 comes along, maybe that 100 lines of prototype code that you wrote, maybe it's now 10,000 lines of code living in 18 different modules. Maybe by 1.0 release, there's 3 entire projects that you've created to support this functionality of your main accessor application. All of those are implementation details, and they're pretty irrelevant to what your end goal really is in any project. Is this worth my time? Is this worth my money to continue sinking my energy and time into it? Now we're talking about a pet project that a group of friends is building. Yeah, we do have that goal of making some money off of this project. But the other big goal of that is just learning. Like, hey, can we do this? Can we build this? Think of all the things that we're going to learn over this process of 6 months or a year. So maybe it is worthwhile to sink a little bit of extra time into building out more things just so that you can figure out how to do it. But if it's for a company, they're not going to have an appetite for you sinking your time and effort and their money into something that just doesn't work.
Yeah, that's a good point. One final question for this area is, if you're leveraging open source tooling, how can you have a competitive advantage?
Are you a SaaS company or are you a non-SaaS company?
Let's say we are a 2-person friend group with no company.
It really depends on what that open source software is doing. So are you attempting to compete with other algorithmic traders? So long as you're not competing with Wall Street itself, like trading firms, then it just comes down to how much you leverage those open source packages. Because the other people that are doing the same thing that we're doing, they're probably using those packages as well. Maybe they have written stuff that's proprietary, but it's not generally just a zero-sum game when you're talking about volumes of 2 buddies writing a pet project. If we're talking about algorithmic trading competing against investment firms, yeah, that's a zero-sum game. You're winning, they're losing, because you're talking about volumes that individual people just cannot compete with. You can't make a trade volume of $100 million in a day unless you're one of those firms.
Got it. So my question was, if you're going to be starting with open source tooling, let's say, everybody has access to that, and theoretically there's no competitive advantage to using that. So at one end, there's a Python tutorial that's a 10-minute read that will get you an LSTM that will trade stocks in some frequency, and it'll work. That probably will not give you a competitive advantage. and you would be winning based on luck.
Mm-hmm.
How do you go from those open source packages to a model/system that has a competitive advantage?
Interesting. You collect data and you look at and analyze the results of what you have built. That's all a prototype is really for, is to get that fail fast, learn fast result. And that comes down to after you run your experiment, and this applies to all ML applications as well. You may be competing against another company or another organization. You may be just competing against yourself, against humans at your company that do this thing. What you want is to capture as much of the information about not only what your algorithm was outputting, but how it interacted with the world. Like, was it used correctly? And this is just setting up logs to be incredibly verbose. So if we're talking about trading, we want to know the exact timestamp that was returned from the exchange server that said, okay, we accepted your bid request at this time. Here was the price that came out after that. You would need to build an ETL pipeline post hoc that combines all of this data source. So what was the actual stock feed price that we're using in real time to predict what we should do? Like, should we bid or not bid? Or what is our volume that we should buy or sell at this particular time? And we need to take that data feed and create an analytics data set that joins our model's output to the actual values of that price. And then we need to go through old school statistical analysis and say, what is the rate at which we were successful or not successful? Analyze what went wrong when it did go wrong, and also what went right when it went right. And then we iterate and you say, okay, it screwed up. Your first deployment of that, hopefully it's better than a coin flip of being like pretty good. Hopefully it's not worse than a coin flip, but maybe let's say we were successful 60% of the time. So we have a 10% overage over just random chance of selecting when a good operation would occur. We go through analytics. We say, oh, the model really struggled when these conditions were found. Well, does our feature data that we're inputting to this LSTM that we built, do we have that data in the model? And we might say, no, we don't. Okay, let's go back to reevaluating this prototype. Let's make version 0.1.1, which is we're adding in these 3 features and doing some clever manipulation of the raw data to generate this feature information that we have correlated to getting it wrong at this time. And then we build it, we deploy it, and we measure it again. This iterative process, successful companies that do ML, this is how they do all of their projects, regardless of what they are, whether you're identifying cats and dogs or camels and cows, as we talked about many episodes ago, or you're talking about detecting credit card transaction fraud or predicting whether it's going to rain tomorrow. You analyze the predictions versus real world activity, figure out what features could have helped explain that based on our understanding of the domain or talking to an expert, and then acquiring that data. So that constant iteration is critical.
Yeah, completely agree. And one analogy that I like to use, philosophy of algorithms and such, is sort of interesting to me. Not that I'm very well versed, but you can sort of think of iterating on prototypes like stochastic gradient descent.
Yep.
So you are at a local point, let's say, and what you can do is determine the local information. So stochastic gradient descent calculates a derivative. You as well can calculate a derivative based on the local information you have, take a step in that direction, recalculate based on local information, take another step, recalculate until you have some sort of stopping criteria. So whether the step size decreases, if you're decreasing step size, whatever philosophy you want to borrow from stochastic gradient descent to define an optimum, that has been a really effective analogy for me. And one thing that I try to focus on is making sure that my derivative calculation is as accurate as possible. So what does that mean? It means that you get really high quality local information that you're very confident in, so that you know that whatever step you will be taking is actually the right step based on local information. So just a fun note that I like to leverage a lot, and building out the skills to be able to calculate the derivative in quotes is very challenging. And people who can do it are really, really effective because they can iterate in almost any environment.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. You know, whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
That's a really clever analogy, actually. I think you should write a blog post on that exact topic, by the way. That's very clever. Because it also brings to mind in SGD, if you take too big of a step, you can miss global minima. And that's something that you see in model training. People are like, oh, learning rate. When you're modifying the hyperparameter for SGD in a lot of these optimization algorithms, if you were to visualize what the loss curve looks like over iterations of that parameter, it looks like somebody slowing down time on an exposure of a picture and then playing pinball. And you just see this ball bouncing around everywhere. It's just going randomly and chaotically. Whereas if you do the opposite effect and you say, hey, I only want to take really small steps, you're going to just settle into some very small area, and you're never going to get out of the trough of local minima. So finding that sweet spot, then that definitely applies to the theory of experimentation when you're saying, I need to make enough changes so that I can measure the effective, as you say, the derivative of that change as compared to where it was before. Like, how much of a magnitude shift was this? Is it that much better or that much worse? So if you just make one tiny little change, it's really hard to find, is this better or not? Usually you might not get that much of a signal there. But if you take this massive change, we're adding in 83 features to this, and we're changing how we calculate 20 pre-existing ones, and we're going to shift the model type as well. But, the data set's going to be, kind of similar. If you make so many changes like that, you have no idea where you are now relative to where you were before.
Exactly. And a couple of notes. Another analogy that's very useful on that exact point is if you were going to implement a new thing and you're going to test it with an A/B test, let's say you have 3 potential features. They're all leveraging different areas of the platform, and you want to see what combination of those 3 features is best. Well, there are a couple ways you can do this. The first is a full factorial test where you test all possible combinations. That's super expensive. Yes. And it turns out if you can assume that each of these values are independent, one of the best options is doing a sequential A/B test with each of those 3 features. So is feature A better or worse? Yes, no. If yes, implement, else no. Then test, is feature B better with or without? Yes or no. Likewise with feature C. That tends to reduce the amount of time that you do stuff. And as Ben, you said, it's really important that when you do add in new features, you can isolate what exactly is causing the increase or decrease in, let's say, lift for A/B testing. But in our case, what's actually helping us or hurting us in building this trading bot. So just one point there. And then another point is, I have a buddy that used to work at one of the fancy companies, which will remain nameless. And they were building a tool that would estimate shrinkage for experiments, and therefore would reduce the lift and essentially leverage some variance calculations. So it would reduce the lift and get us a much more accurate lift. And after they built that, it turns out this company had been sort of pinballing around a local optimum for the past 5 years. So all of the stat sig results over the past 5 years just disappeared. And they had actually been at a pretty solid optimum. So Ben, question for you. How can you philosophically know with our trading algorithm whether we are at a local optimum or at a global optimum? And if we're not at a global optimum, how would you go about approaching developing something that is a global optimum?
Oof. That's like the meta question for the entire field.
Yes.
I can only answer for myself on this one, so not for the industry at large. But it depends on your appetite for, like, if you're making iterative changes to something and you're not really seeing that much of a difference. Like, oh, I'm going to add these 3 features. I'm going to drop these 2. I'm going to, change how my model learns. I'm going to add more data to training. I'm going to, try all these little techniques to get that model to behave a little bit better. And you're running test after test after test. Exactly as you said, that one versus rest approach for, hey, we're just going to modify this one thing, keeping everything else the same, and see what its lift is relative to other combinations. If you're not really seeing much of a change there, that appetite question is, how much time do you have? Like, do you want to continue doing this? And when you're working for a company, and that project might be the sole reason for your team's existence, and you have somebody in executive management saying, hey, make it better, make it work better, make us make more money. You can either continue to try new things and not see any results. That begs the question of, should you be talking about taking on another project that could make the company money in a different way or solve a different problem? There is a point where any implementation for what it's designed to do is going to go into a maintenance mode where it needs to be retrained. It needs to be monitored and, check for health. And you should be continuing to do A/B testing over time to prove that, hey, this is actually working as advertised. But there's only so long you can continue to attempt to try to improve something before you get bored or you're just like, hey, I have better things to do with my time. And maybe that is shifting over to a different approach. In the case of our algorithm trading bot, maybe we solve that to a point where we're really happy. Like, hey, this thing is making us $50,000 a week, and we're just touching, this relatively small niche space in the market that's just working great. Maybe we move to commodities. Maybe we take our $7 million in profit that we've earned. Let's take $3 million of that and let's build a bot that can do commodities trading. See what happens. Let's figure out a new thing and learn about that industry and like how all of that behaves. I think that's a better use of somebody's time. If you can't tell if you're actually escaping from a minima to get to a global minima, then maybe you're already optimized for what you're trying to do.
Got it. So it sounds like the stopping criteria would be the expected improvement over time, money, etc. And once that expected improvement over time and money is low enough, you say, well, we should shift gears, either try a new approach or move on to a completely new project. Is that correct?
Pretty much.
Cool. All right. So we have talked a lot about philosophy, and I wanted to get a bit more technical towards the end. So Ben, we are looking to develop a trading bot that will be executing relatively high frequency trades, looking to make a couple $1,000s here and there, and we want a working version in exactly 7 weeks.
Good luck.
What would be your ideal tech stack? Yeah. What would be your starting tech stack?
Ooh, I mean, we'd have to ingest the prices of things, and it depends on how many stocks we would be going after would determine what our core architecture for ingestion would look like. So any trading bot needs relatively real-time data. So I'd be looking at Kafka. If we're talking about like, hey, we're going to go after 10 stocks, then probably a single Kafka topic will be fine. The volume's not going to be that big. If we're going free tier, we're looking at per second data anyway. So we don't need a huge amount of hardware. It's probably just a single Kafka shard. If we're getting a little bit more ambitious, we're like, hey, we want to go after 10,000. And we actually want to buy some of the more high frequency data that's coming out. That's when we're looking at sharded Kafka where we're maintaining a different topic, maybe in groups of stocks, just due to the data volume. If you're going down to millisecond data, that's quite the fire hose that's coming out. And what you don't want is resource contention and context switching on that VM that's running Kafka. It could get pretty ugly with you're trying to fetch a particular topic while it's being written to. That pipe is the CPU executing that pipe is just kind of getting a little bit overwhelmed. So you don't want latency to enter that. So as part of that, we'd have monitoring. So we'd have probably some form of Grafana dashboard that's like, hey, what is the ingestion rate? What is the retrieval rate from this? And is this doing what it's supposed to do? Are we having spikes in availability and in retrieval time? If I wanted to go cheap in 7 weeks, I'd probably go with Spark just because it's easy to actually read from streaming data, and it's easy to apply a model in some sort of micro batch trigger mode on top of that. I wouldn't be trying to do some sort of crazy implementation where I actually want streaming data to go through directly a model implementation. So I'd start as simple as possible. I wouldn't go LSTM out of the box. My first attempt would probably be something statistical and as lightweight and rapid to iterate on as I possibly could. So conditional logic, and see how that works. And if that just sucks, then be like, okay, let's go a little bit more complex, and I continue to iterate. Maybe we eventually hit LSTM as like, hey, this is the only viable solution here, but I wouldn't start there. But for architecture, I would be making sure that I would be sizing my cluster to read from the topics in such a way that an executor would be matched to a topic and would be sharded appropriately so that concurrent access on that cluster would have the minimal amount of network I/O overhead with switching contextual connections. So if I can merge up each of those sharded topics to a particular executor, then it's basically a straight pipe. So one CPU on one executor on Spark cluster would be connected to that topic, Kafka topic, and just saying, hey, give me what you got, and I'll be processing that from you. It works a little bit differently in practice, but effectively that's what it is. And I would also have monitoring set up on that cluster, and I would be making sure that I am very closely monitoring latency associated with the stream processing of that data. So looking at network I/O, also looking at CPU with a very simple algorithm that I would probably get started with. I'm not really concerned with CPU pressure being very extreme on the VMs. And since it's a streaming implementation, memory pressure is almost nothing. The JVM garbage collect is going to be just purging the heap continuously. And then from the other side, I'm thinking of where do we write this data to? So if we're doing stream processing on micro batches, maybe we're triggering this every couple of seconds. Maybe it's once a second. Maybe it's once every 10 milliseconds. Whatever that periodicity is, we need to sync it somewhere. So I'd probably write it back out to Kafka. And then from there, I would ingest from like a Lambda on whatever cloud platform that we're talking about. So that Lambda, or it could be going to an actual application service layer that we create. But what we're looking for is, does the prediction output tell us that we need to make an action? So that prediction should be something like, here's the stock identifier, here's the number of shares that we should be taking action on, and here's the action we should be taking. Is it buy, sell, how many, on what ticker? And that execution would just be a very simple API connection. We're calling a REST API with our authentication protocol to the trading services and saying, hey, we'd like to place a bid. Here's our header. Here's all of our payload data. Here's our authentication of our username and password and stuff, or whatever sophisticated security we're going to be creating for authentication. It's probably just going to be a token, but that server or that microservice for conducting the trades is what we're going to be focused on. In order to handle the analytics of this after we're actually making these trades. We need some place for that microservice that's taking those actions to write out what the state of what we did. And that would be written probably to another Kafka topic where it would say, I attempted to take this action at this date timestamp. Here's the action that I sent to their server. And then here's the response that I got from the server saying, yes, we accepted your transaction, or hey, we had to retry, or the transaction failed. And that response would be another ETL process that we would be writing to object store with some very simple ETL. Just like, hey, take the JSON, convert it into a table format so that we can analyze it later on.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Got it. So step one is take either real-time streaming data or some sort of batch streaming data, store it in Kafka. Step two is have some sort of modeling technique. Ideally, start very simple that will return either purchase or not purchase or other information like stock ticker. The third step that you mentioned is writing that result out to Kafka. Why would you want to do that?
You wouldn't want executors within Spark to be handling your trades for you. It would be a lot of complexity that you'd have to introduce. Plus, you're operating on a distributed asynchronous system where you wouldn't want all of those EC2 machines to be connecting on your behalf to a REST API endpoint. That could be detected by that endpoint as saying, hey, why do I have 30 VMs all submitting statements all at the same time to buy and sell? And even if they would be different stock ticker prices, but they're all coming from different IP addresses, and it could potentially just look fishy. And we wouldn't be able to, in a 7-week period of time, create an application that could be serialized on Apache Spark, because any code that we'd be submitting to the executors, we would have to serialize over the wire, or we'd have to initialize the cluster with this code available to the executors. It would just be incredibly tricky to build that in such a short period of time. It's easier to just write the output stream to a single machine that can handle this. And then I'd probably just use async IO in Python to submit trades from a single VM endpoint.
Got it. That makes a lot of sense. And then the final point is storing your historical actions, and this would help you diagnose problems and iterate. Is that correct?
Yes.
Cool. Now, one more question is getting back to the modeling step itself. As we've talked about many times, it's often best to start simple, start lightweight, and then iteratively improve. Mm-hmm. What would be your backtesting strategy? So we can obviously train, but would you backtest to see how profitable that strategy actually is?
Oh, you'd have to. I mean, you don't have to. If you don't care about your money, you could donate it to charity or do something more worthwhile than just raw build a model and deploy it and hope for the best. You're probably going to lose everything and you will be having a very bad day. The better thing to do anytime we're talking about machine learning with a temporal component, backtesting is absolutely critical, because you could optimize exceptionally for the tail of your time series, but it does not generalize at all to the data. And since if we're training all the way up to 5 minutes ago and we don't really have anything to test on for the future, you're either eyeballing something, which is really dangerous to do, be like, yeah, that looks good, I think it'll be fine, or you're holding out like the last 100 rows of data and then hoping that that model fits really well on that 100 rows of data. It could fit really well on 100 rows of data or 100 entries in the series. And then it could fall completely on its face by series element 110. Time series models tend to do that if they're not generalized well enough. So backtesting allows us to take the settings for configuration of temporal models and say, okay, start 6 years ago. Train on the first 6 months of data with these settings. Predict on the next 30 days. Walk forward 30 days. Train on that 6 months of data. predict the next 30 days. Or that's one approach that you can do. That's like the stepwise method. The other one is train from beginning of your time series data, do the first 6 months, then do 9 months and predict 90 days. Then add another 3 months, predict 3 months in the future. You take the results of each of those horizon validations because you have the actuals there, and you basically average them up. And you say, you can do the average of the median. I recommend personally average and standard deviation. I want to know what the variance is because maybe there was one particular time epoch that maybe around Christmas every year, the model really sucks. Well, I want to know that it sucks at that, one period each year. So you take that, and that's your optimization metric to say, how well does this actually fit to the data over time? That's the only way you're going to know how safe it is to deploy this thing on something that we can't know, which is what is the future state actually going to be? And even then, there's no guarantees. Especially when you're talking about the stock market, it is an inherently non-deterministic system. It's personally one of the reasons why I've never built one of these things or even attempted to do it, because there's just far too many black swan events that occur. And you have the ultimate latent variable system, which is the whims of humanity. You have people making decisions about how they want to invest other people's money and their own money based on gut instinct. There's a lot of people that are doing it based on algorithms. There are a lot of people doing it based on data. Those serious companies, they're trading in massive volumes because they have a scientifically based intuition that they've achieved through extensive analytics. I've talked to some of these people that do this for a living, and it's pretty amazing the depths that they go to make sure that this is a wise decision. But on the counter to that, you have people that are effectively just playing like they're cowboys, shooting from the hip. There's very little analytics other than, I think this is going to work. Or, yeah, I talked to that guy. I trust that guy. I'm going to take $1 million and buy this stock. Or, hey, everybody else is buying this. I'm going to buy it too. When you have that level of non-capturable data, you have no reason why people did this. Setting aside criminality, which exists, people doing insider trading, like stuff like this happens, and people discuss things that they shouldn't be discussing. The SEC is not investigating everything they should be because they just don't have the resources. So when you put all of those variables into it, it becomes effectively the same as gambling to me, which is why I'm not going to use my own money to mess around with it. But I understand why people do.
Yeah. And I'm not advocating for it one way or the other, but you made a really good point that it's a great way to learn. It's a ETL pipeline, start to finish, with lots of potential modules that you can plug in that would be trading strategies. They can leverage really technical things. They can also be super simple. So yeah, I thought it would be a cool case study for us to walk through a very popular project, which is creating a trading bot.
Yep.
So thank you for your wisdom, Ben. I'm definitely a lot smarter for it. So appreciate it.
Yeah, we should do another one of these actually on something completely unrelated in the future.
Sure. Got any ideas?
I mean, we could talk something that both you and I have experience with jointly. Not jointly, we didn't work on it together, but recommendation engines. Those are always fascinating. How do you get to understand how people enjoy content? There's a lot to unpack with those, and they can get very complicated. But it's a fascinating topic. Yeah, this was fun. And I can't wait for our next two that we're going to be doing, because we're going to tackle some completely unrelated topics as well that are going to be pretty fascinating.
Could not agree more.
All right. So thanks, everybody, for tuning in. Stay tuned for next week, where we're going to talk about stuff like open source contributions. Is it worth it? Yes or no? I tend to lean on the yes, and we'll be talking about why. Building street cred for yourself as an ML engineer / data scientist, and some other fun topics. So thanks, everybody, for tuning in. And until next time, this was Ben Wilson.
And Michael Burke.
Take it easy, and we'll see you next time. Bye.
Thanks, everyone.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.